Data Architect. Course title: Data Architect Fundamentals. Course description. This course provides an introduction to data architecture, which is the design, organization, and management of data in an organization. Students will learn the principles and best practices of data architecture, including data modeling, database design, data integration, data governance, and data security. The course also covers emerging trends in data architecture, such as big data and cloud computing. Module 1: Introduction to Data Architecture. Overview of data architecture. Data architecture refers to the overall design and organization of data within an information system. It encompasses the structure, storage, integration, movement, and management of data across various components of a system or organization. A well-designed data architecture ensures that data is accurate, consistent, accessible, and secure, and supports the efficient and effective use of data for decision-making and business operations. An overview of data architecture typically includes the following components. 1. Data sources. Data originates from various sources such as databases, applications, external systems, and data streams. Data architecture identifies and defines the sources of data, including their formats, quality, and availability. 2. Data storage. Data architecture includes the design of data storage mechanisms such as databases, data warehouses, data lakes, and other data repositories. This includes defining the structure, schema, and storage technologies for different types of data. 3. Data integration. Data architecture includes the methods and techniques used to integrate data from multiple sources into a coherent and unified view. This involves data cleansing, data transformation, and data integration processes to ensure data consistency and integrity. 4. Data movement. Data architecture includes the design of data movement processes, such as data ingestion, data extraction, data loading, and data replication. This involves defining data movement patterns, data pipelines, and data integration tools to move data between different systems or components of the architecture. 5. Data modeling. Data architecture includes the design of data models, such as entity relationship, models, data flow diagrams, and data mapping. Data models provide a conceptual representation of the data structure and relationships and help to define the logical and physical data architecture. Overall, data architecture provides the blueprint for how data is structured, stored, integrated, moved, and managed within an information system or organization, ensuring that data is used effectively and efficiently to support business goals and objectives. Principles of data architecture. Data architecture is guided by a set of principles that help ensure the design and implementation of an effective and efficient data environment. These principles can vary depending on the specific organization or context, but some common principles of data architecture include: 1. Data integration. Data should be integrated from multiple sources into a unified and consistent view to enable a holistic understanding of the data and support data-driven decision-making. 2. Data consistency and integrity. Data should be accurate, consistent, and maintained with integrity across all data sources and data storage mechanisms to ensure that data is reliable and trustworthy. 3. Data quality. Data should meet defined quality standards, including accuracy, completeness, validity, and timeliness, to ensure that the data is reliable and fit for its intended purpose. 4. Data security. Data should be protected against unauthorized access, alteration, or disclosure, and appropriate security measures should be implemented to safeguard data confidentiality, integrity, and availability. These principles serve as guiding principles for designing, implementing, and managing data architecture to ensure that data is organized, stored, integrated, and managed in a consistent, reliable, and secure manner, supporting the needs of the organization and its stakeholders. The role of the data architect. The role of a data architect is critical in designing and implementing an organization's data architecture. Data architects are responsible for creating the blueprint for how data is organized, stored, integrated, moved, and managed within an information system or organization. Their role involves a combination of technical expertise, strategic thinking, and business acumen to ensure that the organization's data is effectively and efficiently used to support its goals and objectives. Some of the key roles and responsibilities of a data architect include: 1. Data architecture design. Data architects are responsible for designing the overall data architecture of an organization, including defining data models, data storage mechanisms, data integration patterns, data movement processes, and data access methods. They work closely with stakeholders such as business analysts, data scientists, and IT teams to understand the organization's data requirements and design data solutions that align with the organization's goals. 2. Data strategy and planning. Data architects play a strategic role in defining the organization's data strategy and planning. They work with business leaders and other stakeholders to understand their data needs and define data roadmaps, data standards, and data governance policies that ensure the effective management and utilization of data assets. 3. Data modeling and design. Data architects are responsible for designing data models that define the structure, relationships, and attributes of the organization's data. This includes creating entity relationship (ER) models, data flow diagrams, and other data models that provide a conceptual representation of the data and guide the development of physical data storage mechanisms. 4. Data integration and ETL. Data architects are responsible for designing data integration patterns and ETL, extract, transform, load, processes that enable the seamless flow of data across different systems and applications. They design data integration solutions that ensure data consistency, accuracy, and integrity, and oversee the implementation of data integration processes. In summary, the role of a data architect is critical in designing and implementing an organization's data architecture. They are responsible for defining the overall data architecture. Thanks for watching. For more information, like, comment, and subscribe our channel.